Today's Daily Dose of Math is about some fractions questions. One of the things that we learn to do and prove we can do in our test is to reduce fractions. There can be a question where that's all you're asked to do. But also, when you add fractions or subtract or multiply or divide, your answer isn't complete unless you give a fully simplified fraction as a final answer. And reducing becomes necessary there. We also have another question that's asking you to find equivalent fractions, or sometimes find two equivalent fractions. So let's look at what we do when we answer these types of questions and see how the same techniques can be useful for more than one question. Let's start with the fraction 27 over 36. If we're asked to reduce it, what we need to do is divide the numerator and denominator by a common factor, preferably the greatest common factor, to get a fully simplified final answer. One way of doing that is to just look for any common factor. If we realize that 27 and 36 both have 3 as a factor, we can divide top and bottom by 3, and we get 9/12, which is a more reduced fraction. It's more simplified, but it's not fully reduced or fully simplified. But that's fine, so long as we realize that 9 and 12 also have a common factor. This time, again, it's 3. And we can divide top and bottom by 3, and we end up with 3/4. We have our final answer when asked to reduce the fraction. The fact that we did it in 2 steps is okay, so long as we manage to get to 3/4 in the end. Maybe, when we're answering this question, we realize that 27 and 36 both have 9 as a greatest common factor, and we divide top and bottom by 9. We get to 3/4 right away. Both of these answers are correct. The second one might be a little bit more efficient. Then we get another question elsewhere in the course where we're asked to find equivalent fractions, or even to find two. What if we're asked to find two equivalent fractions for that same fraction of 27 over 36? Well, what we can do is we can divide top and bottom by 3 again. And we can get 9 over 12 again. And then we can divide top and bottom by 3 again, and we can get 3/4 again. Really, the exact same answer that we did over here, but it's an answer to a different question. And it's correct, because both 9 over 12 and 3 over 4 are equivalent fractions to 27 over 36. When we simplify fractions by reducing them, we are finding equivalent fractions. But what if the student realizes that 27 and 36 have a greatest common factor of 9 and starts off by dividing top and bottom by 9 right away, just like they did over here? Well, they'll get 3/4, and their answer is correct. It is an equivalent fraction, but this one is reduced to lowest terms. What if the student tries to divide top and bottom by 2? This would not be a good idea if we're being asked to reduce a fraction or to simplify a final answer. But when we're asked to find equivalent fractions, the truth is this still works. We end up with a decimal inside a fraction, which is a little weird. But 1.5 over 2 is actually still an equivalent fraction to 27 over 36 and 3/4. Therefore, a student who answered this question this way is correct. I would give this student full marks. But be careful. When you have a decimal inside a fraction, that fraction is not considered fully simplified. So whether you do this or not, which of these techniques you use depends on what question you're being asked. Since this happens in more than one place in the exam for this course, where these very similar questions are being asked, it's important to go back and reread the question to make sure that you applied the right technique and completely answered it. That is today's Daily Dose of Math. Please like, subscribe, and share.